Predicting the weather is something humanity has tried to do for ages. We've come a long way from not knowing whether it's going to rain tomorrow to being able to reliably generate a weekly forecast. But it is still quite hard. Today's episode covers the challenges of using data science for meteorology and the modern tools that have made life easier for data-driven meteorologists. One tool the discussion centers on is Matplotlib, a plotting tool for Python inspired by MATLAB. But before we get to this episode of Software Engineering Daily, we have a message from one of our sponsors. Abhinav Kordia is a software engineer with Clover. We're interviewing him today because he found his job through Hired.com, and Hired is a sponsor of the show. Abhinav, it's great to talk with you.
Great of you to have me on the show.
So listeners of the show have probably heard my ads for Hired where I talk about Hired.com is the job marketplace for software engineers, but I'd love if you could talk in more detail about your own experience with Hired.
Around the time that I actually was looking for jobs, which was it's 2014, early 2014, I started looking for different jobs. And at that time I was based in Chicago. And I really was kind of looking into potentially maybe relocating to the Bay Area potentially. And I didn't really find a good way to find companies that I wanted to work for very easily, rather than going, because there weren't any recruiting agencies that were based in Chicago that would help me potentially reach out to a bunch of different employers there. And Hired.com was one of the first ones that came up because it allowed me to literally just upload my resume and then provide a brief summary of exactly what I wanted to do, what my goals were, what my past experiences had been, and just give my side of the story in terms of what I'm looking for and what kind of company I wanted to work for. And the whole process was very simple, very straightforward, and very hassle-free, which I loved.
So Hired has this high-touch approach that gives each candidate individual attention if they're looking for work on the platform. How did the employees of Hired help you through the process?
I don't know exactly what the term that they gave me was, but they gave me a one-on-one contact that I could approach and talk about issues that I had, any questions that I had about the platform. And they guided me through the process. They were like, this is how you should set up your profile and what you should say and what employers are potentially looking for and all this stuff. And then they were very approachable. I did one-on-one, I think the guy I was talking to was Matt, and any questions I had about how to potentially negotiate, they were very quick in terms of responding and very easy to talk to in terms of exactly what I wanted and what I should be doing potentially to make my situation better.
So do you feel like you had more leverage in the process because different employers were bidding on you?
Definitely. It gives you more leverage in terms of potentially getting a better offer and also at the same time getting multiple offers at the same time, so you have multiple options within a short time period. Getting on Hired, I got job offers from at least 3 different companies where they all seemed great companies to work for, and I would have loved to work for either one of them. And it just provided because when you apply in the process, you explain exactly what you're looking for. So most of the time, the employers themselves won't bid on you if they don't think you will fit into their culture as well. So it provides a good way to get a good culture fit as well as potentially your own personal growth opportunities at different companies. So I would definitely recommend Hired.com as one of the best tools that are out there right now in terms of people looking for jobs in the market right now.
Awesome. Well, Abhinav, thanks so much for coming out to Software Engineering Daily to talk with us about Hired.
Yeah, thank you for having me again. I would highly recommend it.
Matplotlib is a plotting library for the Python programming language. Ben Root is a core member of the Matplotlib development team. He has a master's in meteorology and works as a scientific programmer for Atmospheric and Environmental Research Incorporated. Ben, welcome to Software Engineering Daily.
Hi, great to be here.
What is Matplotlib?
Well, Matplotlib is a plotting library that, as you said, for the Python language that is more targeted for producing scientific publication quality type plots. So the things you would sort of see in papers and journals and presentations and such. But you could use it for a lot more than just that. But that's the key focus, is to help scientists produce plots very, very easily on a wide range of platforms and a wide range of outputs.
Why are visual tools like Matplotlib so important for communicating data effectively in these publications?
Well, I don't know about you, but my eyes just roll whenever I see, a table just full of numbers. And they don't mean anything to me. I just don't immediately grok it. But if I see a line plot, the same exact data, but the line plot, I get it right away. I understand. We're inherently, us humans, we evolved to be visual entities. We take in our environment mostly through our eyes, so we're just so used to viewing information that way that it just makes sense to present things that way.
And I think this is like growing in popularity. You see many data-driven news publications, I think about like 538, for example, that are increasingly using data visualization tools. Have you seen media outlets using Matplotlib?
Media outlets? No, I have not seen media outlets use Matplotlib specifically, but I have been seeing, as I go to conferences and such, and other places that are more scientific driven, I have been seeing instances of Matplotlib there. It's kind of telling it, when you work with Matplotlib long enough that even though they don't say they're using Matplotlib, you can tell with Matplotlib through just the little quirks and stuff and how their presentations, the sort of details that I would probably notice as a core developer that most other people probably never would notice. So it's kind of funny that way.
Give me an example of how someone might use Matplotlib. I was going to say, and just in the sense of like what would be a prototypical project, and at what stage would they could they use the project as is to invoke Matplotlib to build a nice visualization?
Oh, well, I've seen Matplotlib be used at every stage of a development of a project. For example, obviously, you might want to use Matplotlib to help display the pretty plots of your final product, or showing your metrics of your website, or just simply showing your final data. But sometimes you just will run into a situation where you're writing up some software and you're running into this bug and you just don't know what's wrong. And there's something in this one big, huge array of something, and what, you're just going to look through the numbers? No. Just pass it off to Matplotlib as part of your development process or your debugging process, and you display it, and now you can see, oh, this thing is spiking all the way up to infinity, or this got a value here that I totally didn't expect to ever see, or something like that. Yeah, then you can easily see what's going on.
Fascinating. So like a debugging tool almost. So Matplotlib was inspired by MATLAB. Is Matplotlib, can it be thought of as an augmentation to Python that essentially wraps Python in a MATLAB-like environment, or is that too much? Is that too much of a statement?
So, yes, you're right. Matplotlib was inspired by MATLAB. Indeed, the original creator of Matplotlib, John Hunter, he was being frustrated by some of the limitations in MATLAB. He was working on a dissertation for analyzing pediatric CAT scans, or some neuro type thing, neuroimaging type thing. This was back in like 2000, and he just kept running into issues with MATLAB, just stupid little limitations here and there, and then he picked up Python. But Python at that time didn't really have very good graphing tools, and there was this other tool out there called IPython, Interactive Python, but it didn't really have much in terms of graphing tools either. But it was a really good environment that made him feel like it's sort of like MATLAB, but it still didn't have the graphing. So he worked on it, and he tried to submit a patch to the IPython people for what was now Matplotlib, but that patch got rejected. Fernando Perez, the creator of IPython, he was actually in the middle of his dissertation as well, and he said, "I'm not accepting patches for 6 months." So John Hunter went ahead and made Matplotlib its own standalone project to display those images that he needs in the way that he needed it to. So now getting more to your question, does it wrap Python and stuff? The syntax of Matplotlib is inspired by MATLAB, but there's certain aspects of it that he couldn't perfectly duplicate because of the way how Python is structured. But he managed to capture a lot of it, and in some ways, I think actually made it better. But that's my opinion of MATLAB. I also am a defector from MATLAB.
Do you say that? Do you think MATLAB is feature bloated?
Oh, feature bloated? No, I don't think. Actually, quite the opposite. I think MATLAB actually has the right amount of features and stuff like that. I think the problem with MATLAB is the basic design of the language itself. Is fundamentally limiting and is so geared towards mathematics and doing things like that then the sort of higher level programming such as that you might want when you're putting together a system, such as doing string manipulation, command line argument handling, doing function calls in a sane manner, organizing your source code. Like MATLAB, you basically got one file, one function. That's it. So every function you want, you got to have another file, or you come up with the module type thing. But they're so complicated and it's not easy.
So it sounds like maybe this is the criticisms of MATLAB or the warts of MATLAB. It sounds like they have come out of the closed source nature of MATLAB. Would you say that's accurate? Or is MATLAB is closed source, right?
Yeah. Well, okay. Closed source in the sense that there are many aspects of the MATLAB code base that you can view, but they're all copyrighted and they're not licensed with an open source license. So there's lots of code that you can view, but the core part of MATLAB, the real engine and stuff like that, yes, that is completely closed source. You cannot see it. You cannot, and it's not like the community can really provide a lot of feedback. And I think that's the key with a language like MATLAB is that its development is completely driven by the company rather than really getting good feedback and collaboration from a community. Now, yes, indeed, there is a community around MATLAB for helping people develop code and things like that. But you don't really see that sort of stuff as you do see with, let's say, Python, where Python you have the PEPs, the Python enhancement proposals, and with other languages like C, C++, there's people submitting proposals to improve a language all the time. MATLAB, you don't really see that. And yes, MATLAB, they do make improvements, incremental improvements, stuff like that, but it's not coming from the community. It's more driven from one side. And so I feel that that's a bit of a detriment because you don't have everybody's voice involved.
Interesting. So let's get back to Matplotlib. Tell me about your involvement with the Matplotlib core development team.
So the way how Matplotlib does its development, obviously being an open source, it is through the community. So for one thing, as always, at any point, anyone can submit a patch or a wish list item or something to the GitHub site, our GitHub page, and ask for a particular feature or say, hey, I've been tinkering with this thing. Here's what I have so far. for this feature I would really like. So that's where actually we get a lot of contributions from. I actually don't write as much Matplotlib code as I used to. A lot of my time is actually spent reviewing these submissions from people outside of people not of the core team. So that's where we probably get maybe about a good quarter of our lines of code. As bad of a metric that is, but lines of code, we probably get about a quarter of them from outside contributors like that. And then for the really the meaty type stuff, we have the core developers, and then we also have our repeat visitors. The people who are the people who contribute from time to time. They're not the core developers, but they got a niche here or there, or they're actively using Matplotlib, and so they tend to have a lot of good ideas from time to time. So they'll submit some things, and they usually get accepted without much work. The more meteor type stuff, we tend to do what we call MEPs, Matplotlib enhancement proposals, where we really try to hash out how it is we want to do something, because Matplotlib, a lot of people depend on it to have a very stable API. And so we pride ourselves in, if you wrote code to do something, to make it some particular plot or something, and this has actually go back to scientific computing and publication stuff. If you wrote code to make a plot, you should expect that code to still work 2 or 3 years later. Because, even with the latest version of Matplotlib, or at least with very little tweaks, because people need, it often happens when you're doing scientific publishing, is that you'll submit your paper and it'll go through a few rounds of revisions, and then it'll finally get accepted a year or two later, and then maybe a year after that, someone's going to contact you and go, I'm having trouble with this and that, or I got some new data. Could you help me try to get this thing, an update to the data set or something? Could we try to make a new pilot like that? You don't want to be fussing around with a brand new Matplotlib API. You just want to pull out that script that you had already that worked and feed it the data and go. And so we really pride ourselves in keeping that backwards compatibility for a decent amount of time. But then,
tell me how you got involved with Matplotlib.
Well, as I said earlier, I'm a defector from MATLAB. Being a meteorologist, I was doing plots of radar, and the type of radar plots you see on TV that were called just reflectivities. But there are other plots too. They're called Doppler velocities, and they're colored completely differently. And I was trying to display both of them at the same time, one with one color map and one with the other color map. And in MATLAB, you just can't do it. It's impossible to do. I've been told now possible, but at the time I was doing it, you just couldn't do it. And it was driving me utterly bonkers. And there were other issues, such as trying to display the counties, because I needed to see, I knew that there was a tornado that passed over such and such county at such and such time. And I'm looking at my image and I'm going, no, it's over this county, not that county. What's wrong? Is my data wrong? Is it the display? I just couldn't be sure. And I couldn't inspect MATLAB all that well to be sure that it was displaying the stuff correctly. I could be sure that Matplotlib was doing it correctly. And so a coworker at the time, he was also a frequent contributor to Matplotlib, and he started showing me some code to use, and it looks so similar to MATLAB. And over the course of about a month or two, I just started converting all my MATLAB scripts over to using Python and Matplotlib, and I just fell in love with it. And so there was that aspect, and that got me hooked as a user of Python and Matplotlib. But then what got me involved was well, Matplotlib isn't perfect, and I kept running into bugs in Matplotlib because I kept using Matplotlib, kept using it for things that they weren't originally envisioning it to be used for. I kept pushing its boundaries and such, and I just kept submitting bug reports after bug reports, and then eventually I got comfortable enough with Python. I then started submitting patches, and eventually, when I submitted enough patches and suggestions for enhancements and stuff like that, finally John Hunter, he just said, "That's it. We're giving you commit rights."
It's so interesting because I find that this is how people tend to get involved in open source. It's almost like a happenstance, scratching their own itch sort of thing. They need something so bad, and then they just get fed up with it, and they realize nobody else is going to do it, so they do it themselves.
Exactly, and that's why I love open source, because I'm able to scratch that itch. Meanwhile, in a language like MATLAB, I can't scratch that itch. So it's kind of like you're stuck in a spacesuit or something, and you just can't scratch your own nose, and it's frustrating. And so that's why I always felt like switching over to Python was very liberating. It didn't have to be Python. It could have been another open source language. But moving away from MATLAB was the more important thing for me, was just get off of... I kept running into issues, and I can't... I'm a perfectionist. I just can't leave it alone. So...
Yes. Engineers love automation, and Wealthfront automates your investing. As a software engineer, there are certain processes that you want to execute no matter what, like integration tests during a build. You wouldn't execute integration tests manually. You would use a continuous integration tool like CodeShip or Jenkins to automate your integration tests. Wealthfront is a tool to automate investing. Just like a continuous integration tool runs your tests automatically, Wealthfront can reinvest your dividends automatically and perform tax loss harvesting automatically. To get your first $15,000 managed by Wealthfront for free, go to wealthfront.com/sedaily and get started with Wealthfront's layer of automation on top of your portfolio. Wealthfront.com/sedaily. Check it out. It would support Software Engineering Daily, and you will get $15,000 managed for free if you sign up. Automate your investing. Get back to the things that you can't automate, like writing code. So, you discussed making your way into Matplotlib through your background in meteorology. I don't think I've done any other shows with people at the intersection of software and meteorology, so I'd love to discuss this. Describe how you got involved in describe you were in meteorology first. Describe the point at which you had to start doing software engineering around meteorology.
Software engineering. Now that's I like to make a distinction between doing software and doing software engineering. I was doing software very early on. I would say probably my junior year in college. I was regularly writing up code to do odds and ends in meteorology. For example, at Penn State University, where I graduated from, they had what's called the campus weather service, and I had the morning shift. I had to get up at 3:00 in the morning and trudge over to the weather building, and then had to go and do a forecast all by myself, because how many other students are going to get up at 3:00 in the morning and do that? And so I ended up making some Perl scripts to go and grab the various forecast products from various places and then just display it on it, in my console. So I just have a quick heads-up display of all the temperatures and what it's going to be cloudy and stuff like that. And I'm like, okay, good. That was like probably my first major significant piece of code I made, was just something that just made that job easier. Now, I would not call that software engineering, because guess what? I don't have that code anymore. because at that time, I didn't know a darn thing about version control. I didn't know a darn thing about writing up comments. So even if I did have that code, I wouldn't understand one bit of it anymore, let alone the fact that it was Perl. But sorry, Perl people out there.
It was never truly understood in the first place.
Yes, it is that much of a masterful language. But then, I didn't understand all that stuff because I never was taught that, and I never at that time ran into a situation where I would need it. And so it wasn't until a few years later that I then started paying the price of not knowing version control, not knowing coding practices. I need to quickly change this software around to do something fairly different. Did I code this? Did I architecture this piece of software correctly so that make that easy? I didn't learn those things. I wasn't taught those things. I learned those mistakes literally through the school of hard knocks. So I would then say I was doing software engineering by the time I was working on my master's. But even then, it still took me a while. And it wasn't until I started getting actually involved in Matplotlib, and by the example of other people who were software engineers, or at least had software engineering training, that then see, if I were just simply to code this up this way, or if I were to just do these sort of, practices, or to understand, how to write good comments, so that way 6 months from now, I understand what the heck I was thinking 6 months ago. Yeah, I then started to understand that better. And so I started writing up code better that way. And so I would say around the time I was working on my master's, I was really starting to get heavily involved in writing up code as being like I'm doing more coding than I am doing science in how one might traditionally define science.
And with this effort at the intersection of meteorology and software, you got your master's degree and you wound up as a scientific programmer for Atmospheric and Environmental Research Incorporated. And throughout that work, I'm curious about the problems that you encountered with the scale of data that you encounter when you're working with weather data and atmospheric data, because there's almost an unlimited spigot of data. So I'm just curious how you think about the volume of that data.
Well, to help put just perspective, some people who may not realize just how much meteorological data there is, you can basically divide out the type of data that we have every day as model data. So you probably would hear about the European model or, the other sort of models that are available. Those are all different weather models that run by different organizations, and they all produce output data, and you got to have, data for, every hour, every half hour or something like that. And it's for every single variable that at whatever resolution it is. So, you're talking, hundreds and hundreds of gigabytes of data every hour. And then you have the observational data. So some people may have noticed as you're driving along the highway off to the side, you might see some strange little structure, that's only probably about, 10 meters high or something like that. And it's, that's a weather station. That's what's known as an ASOS station, an automatic surface observation station. And that thing, the amount of data that's coming out of that thing isn't huge, but we got thousands of those all over the country and all over around the world, different types of stations. So you have those sort of observational data. Then you got the radar data. Again, hundreds of gigabytes every day from every single radar site. And there's about 120 of those for the NEXRAD system alone. Then you got the various satellites. And again, we're talking hundreds of gigabytes again every single day from the GO satellites, from the polar orbiting satellites. You got unbelievable amounts of data. And operationally speaking, NOAA is the National Weather Service, NOAA, and all that. They're fusing all that data together to make your daily forecast down to the hour, down to 30 minutes, doing that 15-minute tornado warnings and such. That stuff is continually being assimilated all the time. And that's why when you hear about the supercomputers that are coming out, I swear half the time the supercomputers that are coming out is for a particular organization, for a particular meteorological organization. So Europe or the U.S. or Japan or China, they all have at the top of their charts a weather supercomputer, at least one of them. I know the U.S. has a couple of them. Europe has a couple as well. So we're always at the forefront of just massively fusing all this data together all the time. And that's just for the forecast. Forget about analytics and statistical post-processing. You got hazards forecast. You got your logistics implementation. So, you got a forecast of snow that's going to be going across New York, and you got a shipment that's going from Massachusetts down to Pennsylvania. Can you get your analytics in such a way that you can optimize that truck so that way it doesn't get hampered by the travel or flights? The airlines, they all employ meteorologists themselves to go through all this data and process all this data to make sure that the flights are least hampered by the weather, because you can't change the weather, but you can change the flights. So
I'd like to understand how this data from all these different sources gets collated and turned into API endpoints, I guess, or how is it accessible? Like, do you receive giant files, in batches over FTP every morning from deprecated systems, or are you getting constant streams in, just throughout the day, or you can ping an endpoint, or give me an idea of how the infrastructure for how weather data moves around the world.
Yes. It was all of that.
All of that.
It is an utter mess, unfortunately.
Right.
It all depends on which source you want the data and how quickly you want that data. So if you want radar data, you're going to be going to a completely different source, and you may or may not have access to it may be somewhat difficult to get up to the minute thing. You can get really easily up to the minute, like, process stuff. But if you want the raw data, you got to go and download it directly from a particular service or whatever. There are a few different ways to do that. But if you're okay with it being, let's say, 6 hours late, that's somewhat easy. There's this system. Why am I blanking on the name of it right now? It will come to me later. The system that helps disseminate the data, and actually it's a bit of a funny story. The whole system was actually based off of how data was originally disseminated like 50 years ago. And 50 years ago, basically it was all just phone calls and what were called die-fax machines. These were the precursors to fax machines. And it was this weird protocol for being able to do it, and they still use it. They still use it as the basis because it worked, and so you can actually send data through the stuff. Not that we use die-fax machines anymore. We actually have computers at the ends of them instead of fax machines. But you get these data through that, and that's one particular system. But then we have a whole bunch of data that you can get just through. Anyone can grab it off FTP. So you have to keep querying the system for the files. It's not like they get pushed to you, unlike the first system that I was talking about that I still can't think of the name of. So you have all these different systems, and then unfortunately, however, the organization of how all this data is. It's just a complete, mismatch of things because different organizations, different divisions within NOAA and other places are responsible for maintaining that data.
So how does it get collated and joined? And I think of the weather, the way that weather is predicted as this collation and machine learning process. How is that reliable if all of these different data streams have different schemas and are coming in at different times? How is that orchestrated?
So there's for doing forecasts, there's this concept called data assimilation, and there isn't some magical system that just makes all this data magically, come together or anything like that. So that's how all those formats and stuff come in. There's a few standard formats that things go, and we're talking about mostly image data, a bunch of point data, so you can break it down to basic concepts like that. And there's a few formats to work with, so that's not totally difficult, especially when you're talking about operational type products where you have fixed feeds with known data. Yeah, you just code it up for each one of those different feeds, and you convert it all into a 2D, 3D, or 4D array, whatever you want, 1D array of points and things like that. Yeah, fine. That isn't the terrible spot. The terrible spot is dealing with buggy data. Because, those ASOS stations I was talking about by the highway, you get a car crash into one of them, and, all of a sudden once one of the sensors starts putting out, every few days, puts out an odd value, got a negative 999 every so often. Or funny story about 10 or so years ago, one of the ASOS stations in, I think it was North Carolina, they had to put out a correction for the past year because apparently a frog was jumping into the rain measuring thing every so often, and it would cause it to spike a rain measurement. It'll think that there was 2 inches of rain in the past 5 minutes. And,
oh, man.
And so it took them about a year before they realized that, it was doing that. You get other sort of noisy data time when the sun sets or the sunrise. If a radar site is at that particular moment looking at the sun, you have to throw out that data because the sun blinds it for a moment. It's rare, and that tends to happen at different points in the data processing thing. But there's a whole bunch of data cleanup and such, and then you go and you assimilate it all, and you basically try to. It's like a giant puzzle where you may or may not have all the pieces. And so when you're missing some of the pieces, you look at all the data, you look at the other pieces around it, and you go, well, it looks like you're in the middle of a field of flowers here, so I'm going to kind of draw my own puzzle piece right now and just kind of plug that in right now. That's sort of data assimilation, and that kind of helps go and make the weather forecast that you guys use every day.
Right. So let me ask you, weather seems like one of these fields that can really take advantage of the decrease in cost of computing. And, obviously every business in the world can take advantage of AWS, but this is one of these things where it seems like the applications of AWS and just decreasing cloud storage in general, decreasing cost of cloud storage in general, you can really feel the impact of it. So have you felt like the accuracy of weather predictions has measurably improved over the last decade or so?
Well, okay, you're asking two separate questions here. So
I guess I am. I'm making an assumption and then asking a question, assuming that assumption is correct.
Right. Yes, we know that weather forecasting has improved on a whole bunch of different fronts. But one thing we have found And as a matter of fact, you may not know, this particular week right now in January, we are having what's known as the AMS annual conference, the American Meteorological Society annual conference. And that's the big shindig for meteorologists. It's the Comic-Con, if you will, of meteorology. And there were actually some very fascinating presentations that were given this week. One, finding that just simply increasing the resolution of these models is not going to, while it would decrease the error in the short term of, a day or two, it doesn't increase what's known as the horizon of predictability. And there's a theoretical limit to how far ahead you can predict certain things. And just simply increasing the resolution of it really doesn't move that horizon at all. But that horizon is like at 2 weeks and such. And that's also based on, are you talking about the daily type weather, or are you talking about, El Nino type stuff? El Nino and other large scale type features, we can predict that sort of stuff out months ahead. But daily type weather, you got about a limit of about 2 weeks. And no matter how much computational power you throw at it, we're really not going to move that 2 week limit. That's a theoretical thing. We haven't hit 2 weeks yet, but we're probably pretty decent now at 7 days out. And we stretch it out to 10 days. Sometimes we get a pretty good forecast for 10 days out, but 7 days out, we're getting pretty good at that. Whereas when I was a kid, a 5-day forecast was that was a laughing stock. You'd be pretty good for with a 3-day forecast, but 5 days out, you better not be planning your picnic. But now you're talking about AWS, and there was a fascinating article a few months ago in BAMS, the Bulletin of the American Meteorological Society, where they actually analyze the potential of using cloud services like AWS for doing numerical processing for modeling. And it was interesting. And I'm going to say right now, no. With AWS and things like that, you're not really going to get your bang for the buck as having your actual iron, your own actual supercomputer and working at it. What AWS and stuff will be very useful for is robust data dissemination. So making it easier for people to get data and to send data and to collect data, because then you can, if a location goes down and stuff, you just route it around to one of the other regions or something like that. Whereas, right now, we run the models in 2 places and the data all goes through pretty much the same pipe. And so if something goes wrong, you're kind of hosed. So you can gain robustness and such, but the problem with numerical computation is that it's not like a lot of other data processing where once you use that array, that piece of data in the array, you really don't need it again. And so when you get down to the actual chip, you can hold a few pieces of data and do that operation, and then it leaves that chip, on chip cache, and that's fine. But with numerical processing with weather, these formulas are so complicated, you need that piece of data many, many times. And so it's going on and off that chip many, many times. So you're paying a penalty already on the iron. But then when you're on AWS, on the cloud services and such, you're paying more of a penalty because it's virtualized. Then on top of that, when you're computing things point by point, you're usually computing derivatives and derivatives of derivatives. And so that means you need data from your neighboring points. And those neighboring points may not be on the machine you're at. It may be in some other machine. And so you're talking about lots of interconnections. And so usually with these supercomputers, I/O is your big bottleneck. And with AWS and other virtualized cloud services and stuff, your I/O is even worse.
Oh, okay. That makes a lot of sense.
Yeah. So, and I'm talking about I/O from RAM to chip and from
Sure.
disk to RAM. I'm talking about all those IOs, and you got all sorts of interconnections, and you got to have all these different threads and processes talking to each other all the time, and you're talking about doing it over hundreds of chips. You're not going to get that on a single die. You're going to be having that spread across multiple machines that are all virtualized. Yeah, you got a problem. So they're finding that you can't run these numerical models very efficiently on services like AWS, but data dissemination and other sort of data cleaning and other sort of things like that, that's where you can get some decent value.
Okay. I want to talk so we're talking, abstractly about doing stuff with weather and data. I'd like to talk more concretely about your work as a scientific programmer for Atmospheric and Environmental Research Incorporated. Can you take me through a typical day for you? Give me a description of the type of work that you're doing.
Okay, so the company I work for, AER, they primarily, besides doing research type work, that's where the company started off as, was getting research grants, for things atmospheric and environmentally related, and completing those research grants through the NSF. They also do a lot of work for insurance companies. So insurance companies, they get insurance claims for damage to their roofs. They get insurance claims for damage to the cars, stuff that may be weather related, lightning strikes, hail, wind damage, ice freezes, and things like that. So insurance companies, they come to us, and they for one aspect of it, they try to figure out, okay, in this region, how likely is it that such and such roof would get damaged? And so then they can, with that sort of knowledge, they can then go through and figure out, okay, there's this much risk, so I'm going to set my premiums and do all the typical underwriting type stuff that they would do. The other aspect of it is confirmation of claims. Is this claim false? Can we detect fraud and things like that by someone puts in a claim for hail damage, and we go and take a look at the data that we have, and we find, there was a hailstorm 5 miles from there, but this guy's taking advantage of the fact that there was hail nearby, but not at his location, or something like that. We might be able to detect things like that if it's systematic or things like that. Can you tell me a strange or exciting or interesting anecdote from, just stuff you found from looking at weather data in such detail? We have. So a funny thing that we're starting to, I was not the one to notice this. It was one of the other analysts that noticed this, that we would find that people were reporting, some people would be reporting damage at the first hailstorm of the, I don't want to say the new year, the first, whenever their premiums are reset, for the year, so their deductibles are reset. But we will find that, let's say, that first storm or whatever was a rather weak storm. It only produced like pea-sized hail or whatever. But they would report the damage then, after their deductible had reset, or something that. So the damage actually happened maybe 3 or 4 months earlier.
Right.
And we can detect that. We can see that there was a more significant storm at that location 3 or 4 months before, and we can go, this may have happened actually earlier because the sort of hail that came down, at the time they're claiming wouldn't have caused this damage. So we're sort of seeing that pattern. Whether or not it's really true or not, what the reason behind it, that's up for the insurance companies to figure out. But so one of the analysts did notice that there was a bit of a spike in reports for the first storm after the year, and it's like, okay, but the first storm of the year is usually pretty weak, and yeah. So that was,
Okay.
yeah, that's a fun little thing.
No, that's a really interesting story. That's fascinating. So, I'd like to talk some about the future, both in terms of meteorology and data science, and I guess Matplotlib. We haven't talked too much about Matplotlib, I guess, except for the beginning. So, tell me what is the future of meteorology and data-driven meteorology?
Well, that's really hard to say because I think meteorology has always been at the forefront of weather data and data processing in general because it always has been pushing the edge. So it's kind of hard to say where is it going to go when we're already at the bleeding edge of things for the most part. I think what's probably the better question to ask is about the meteorologists themselves. Where are they going? And what's the future meteorologist going to look like? And I think that is vastly changing because as I discovered as I was an undergraduate student, I was slowly discovering how using software and such to help me with my day-to-day tasks was making my job easier and making me way more productive. And but yet at that time, the classes and stuff weren't emphasizing that. They were teaching us how to use certain software tools, but they weren't. Jasmine, the cat.
I figured.
Yeah, they weren't teaching us how to. They were teaching us how to use software tools that were made for meteorologists, but they weren't teaching us how to make the tools ourselves. I'm seeing that as changing. I'm finding, for example, a lot of people are grabbing onto what's known as software carpentry. If you go to the website, softwarecarpentry.org, fantastic set of tutorials and stuff that are designed to teach scientists, not just meteorologists, but scientists, how to become, follow good software engineering principles, version control, shell scripting, learning how to use R or Python or some other useful programming language to do their day-to-day scientific tasks, and and then relate, teach it to them in such a way they can relate to. So, teach version control as if it's like your logbook, and teach that you keep your log. You don't ever use a pencil in your logbook because you never erase. I think that for version control gets kept like that. And then shell scripting, that's helping you to make it easy to run your experiments and things like that, and you can keep your log files as your experimental output and your notes, things like that. So software carpentry done a fantastic job of trying to teach scientists that, and so some meteorology programs have actually started to adopt some of those tutorials and such into some of their courses, and some places are actually starting to make programming courses mandatory as part of graduation. And so I think that is a great thing that's starting to change. We're getting the next generation of meteorologists are going to be much more computer savvy than, and when I say computer savvy, I mean software savvy, in that they will be able to be handymans, if you will. That crazy neighbor of yours who's always tinkering in his garage and he always has like the weird thing come out. We're going to have meteorologists that are going to basically be like that. They're going to be creating stuff and making things that may or may not become the tool that creates your next forecast. But we're starting to get meteorologists to see how important that is for their development plans. And I think that's where the future of meteorology is. It's in the meteorologists themselves.
Very interesting. Okay, well, I guess final question. What are you working on right now with Matplotlib?
So right now, Matplotlib, we are in the process of getting ready for the big style change. We're going to be putting out Matplotlib 2.0 real soon, hopefully. I know we people who have been following Matplotlib, we've been promising it for like the past 6 months or whatever. We will. It's just the funny thing is some people were saying how the rabbit holes they've been falling down were infested by dragons, and I said, well, they're thinking of the Monty Python and the Holy Grail. I said, well, there's some dragon holes that are, you got to watch out for the rabbits in those dragon holes too. So, so yes, there's some rabbit-infested dragon holes in the Matplotlib code. So as we were doing the big style change, we were finding all sorts of bugs and such. So we want to get it right before we put stuff out. So my big work right now is Mike Dropboom. He basically wrote like a quarter of Matplotlib, and so he did a major refactor of the image process, the image displaying portion of Matplotlib. And one of the big limitations always been it always had to be rectilinear, and you couldn't do a log scale. Well, you could sort of kind of do a log scale, but you had to do a trick first in order to make it work. Or you couldn't do polar coordinates very well, or you couldn't like skew it and do other sort of weird transformations and stuff. After I'm finished reviewing it, which is what I'm doing, I'm reviewing the code. We will be able to do arbitrary transformations on images, and image viewing will be faster and more memory efficient because, man, those rabbit holes are nested. There's a weird network of rabbit holes under there. And we were doing all sorts of inefficient stuff, and we were just flabbergasted when we actually started digging into some of that code. You think you're really awesome 10 years ago when you wrote that, and then you look at that code and go, what were you thinking? So there's that aspect. Again, there's going to be lots of arguments over some of these style changes because, some people just don't like change, and so we're going to be going over that, a lot of discussions on that. There's the new property cycling stuff that I finished a few months ago. We got to still work out some kinks in there. We have some people that are proposing a certain notation for specifying colors, and there's a big argument that's going to be coming up on that because personally, I don't think that the notation should be limited to just colors, but should also help make it easy to bring in, line styles, so dashes, things like that, or what the hatch fill should be, or what the face color should. I want to be able to control a lot more things, and so there's going to be the whole argument of, well, do we do just colors, or do we do more than that? What does the do we refer to this part of the property cycle, or do we refer to a whole bunch of stuff that we have to hash out online? And then, of course, there's just always the ongoing, every day, people sending in bug reports and us going, oh, man, that's broken too?
Yeah. Well, that's all super interesting. Ben, thanks for coming out to Software Engineering Daily. It's been fascinating talking to you about weather and Matplotlib and everything that's going on in that space.
Mm-hmm. It's been great talking with you too.